Hello, hello. All right, looks like my audio is working. I think we should be pretty okay today. I apologize for the worst mic quality. I have the Yeti in front of me, but I'm actually just using my headset just because some technical difficulties, but that's the theme of this show at least. So, welcome everybody to the November Rust Game Dev Meetup. And so this is a meetup that is meant to show off what game developers have been working on in the Rust language over the past month. And so, what we want to do is shout out the awesome work that's going on. We want to give everybody an opportunity to talk with one another. And then also, yeah, just kind of see what's going on. So, for this month, we have. Oh yeah, so shoutouts. If you have a project that you're working on, if you add it to the Twitch chat or the YouTube chat or the Discord chat, I'll make sure to shout it out so you can kind of see where everybody's at this month. And this month we're going to hop right into it. We have three different presentations today. Ren 3 from CW Fitzgerald. We have Tarash coming to talk about Dotrix. And then we have Kevin who's going to talk to us about Graphite. So we'll be back in just a minute. All right, so first off, we have Tarash here to talk to us about Dotrix.
Yep, thank you. Hello, everyone. I will show you two things that are new in Dotrix. First thing is we've finally implemented state stack. You can check it on this example. I have now a simple skybox and the system that controls the camera. And when I press escape button, to the state stack, I push another state, which is called paused state. And as long as controlling system is not configured to run on paused state, you can see that it doesn't work. Instead of this, you have some window menu, you can resume the work and restore it. And by this stack model, we've implemented stacks management. I will show you how it looks in code. Each state can be a data structure with data or without any data. You can assign any system to run at any state with multiple possibilities. For example, you can say that, hey, I want this system to run on any state but paused state. Or, for example, say that I want this system to run only on this state. And you can combine these rules. So, for example, you can have a system that runs on several specific states, or opposite, doesn't run on some specific states. As I said, it works like a stack. You can push, you can push something to this stack, and also pull data from this, or use data from the state. And this is actually a good example. You have a main system that, I don't know, implements some main logic of your game. In this case, it allows you to, it controls the labels on the screen and nothing more. Shows you some instruction that you can press escape to switch the state. And as soon as I configure this function to run only on pause or only on main state, that in this case, I can simply use expect on the state, get it, modify, and so on and so on. We made it by request from one developer who makes a game, and he wanted to present it today, but he wasn't able. Unfortunately, maybe next time he will show it. He used it exactly for this scenario to have a game and pause it on the when you enter menu. And the second thing that I would like to show you is our editor, which is under active development. And currently we're mostly working on terrain part. So it looks like this. I will choose some bigger terrain. We've implemented several brushes. You can see how the brush looks here. You can change its size. You can also change intensity and it will go faster. Or opposite, you can make negative intensity and dig into your terrain. There is also flattening brush that allows you to make some average value of the terrain size, and you can use it to sculpture your terrain, make some roads, something like this. Such a beautiful mountain. And also we have a noise brush that can add some noise to your terrain, make it more realistic. And of course, you can adjust this noise, make it change scale, change linearity, persistence, number of octaves, frequency, same as intensity, like this. And when you finish, you can export the file. And in files, you can see our height map that we made. There are some known bugs in this implementation, some things that we will continue working on, like better brushes. You can see some artifacts here because of the brush, some more presets, some more possibilities for this. Also, there is no import possibility at this moment, but you can always start from scratch and draw it once again for something, a mountain, make some, I don't know, volcano. I need some smaller size. Now you have some volcano. So it looks like this at this moment. It is in on GitHub in separate branch. If you go to the repository, there is a link in README where you can go to the branch, pull it, and try it out. That's it for now. If you have any questions, I would be glad to answer.
Awesome. It's really cool to see a lot of this progress on sort of what's been going on. I was sort of wondering a few different things. So, like you described the stack system that you're using to have systems run together. But what I'm wondering is like a stack tends to be very good, like when you're doing like one thing after another after another. But then you also described that the systems can run together in parallel. So, how does that look when you're integrating with the stack?
What do you mean run by parallel?
So, I think you mentioned that some of your systems are designed to run at the same time. But then you also showed that there's a stack that keeps track of these different systems, I think. Or unless I misunderstood it.
It's a little bit different. I will show it here. States are stored in the stack, and the last state pushed to the stack is active state. And the system can run only on one stack, or only on one state, or on several states. For example, you may have, well, let's speak about game like, I don't know, Fallout. You can run on the desert, and then you can enter some house, which is actually an instance. And in both cases, you need systems that runs all the rendering stuff, all the physics, and so it's actually the same. But for when you are in the house, you some specific system. And in this case, you can configure your system slightly. In Dotrix, all systems runs one by one. At this moment, we don't have any kind of parallelization on this level. And the systems run one by one, and depending on the state which is currently active, you can run some system or ignore some systems.
Okay, so yeah, I think that makes sense. So like the state stack is more about like you've entered a house, and so right now at the top of the stack you're in a house, and then you might have, for example, that you're in this biome as like the state right below it or something like that.
Mm-hmm.
Oh, interesting. I like that idea a lot. That's a yeah, pretty cool way to be able to add different systems for different states.
Maybe some better example again on the if you speak about Fallout, you always have a radio. You can not always, but you can have a radio in this game. You can listen to it when you are walking, and when you, for example, come to the computer and start interacting with the computer in the game world,
Hmm.
you start seeing the screen, and your controls for movements are not working anymore. But you can type on the computer, for example, or do some other interactions. And there is a different rendering systems, different control systems, and so.
Okay, yeah, I think
But
that's a good way to look at it.
in both cases, you hear the radio. But if you, for example, go to the main menu, then game radio doesn't work.
Hmm.
Here's some default music.
Yeah, and in chat, we're talking a little bit about like how this is like done in Valorant a little bit for the UI as well. And so, yeah, this is a pretty cool way to do it. The next thing I'm wondering about is so you have the world editor. If I'm not mistaken, it's called a Mystic world editor.
No, Mystic is just some redundant thing because it's a working title of our game,
Ah, okay.
but just the title. I just
All
forgot
right.
to change it.
No worries.
It's it will be a part of the Dotrix. The project started in our private repository, and later we decided to move it to public.
Hmm.
So
Yeah, so this is pretty cool
not just
because I've
clear.
been doing a little bit of stuff with like some just different height map generators, mostly in Godot. But I like that you're able to take what you make in here, and then if you just export it to a height map, then I assume that you can really use it in anything else. And so I guess is this a tool that's designed like you download the Dotrix engine and then it comes with this, or is this sort of will this be separate from the Dotrix engine?
At this moment, it is in mono repository of Dotrix, and I think it will stay like this for a long time because for us it's easier to maintain it like this.
Yeah, that definitely makes sense.
And we wanted to be a tool useful for some common things like create a height map, generate some world with it, put some objects inside of this world, and make some water,
Hmm.
whatever, I don't know, choose a skybox, I don't know. In the end, I want as an output Dotrix have some kind of a world configuration file which will keep entities that should be spawned, where they should be spawned, and the format of this file will be some plain text format like, I don't know, YAML, TOML, or something like this.
Okay.
Of course, for height maps, there will be binaries. At this moment, we use PNGs due to you can open it in a viewer and see what you have done. And the stage, like many editors, they provide some proprietary formats of assets. We don't want these. Maybe we will have it as a separate thing, like you can prepare everything in this plain format and then pack it and distribute. For example, distribute over the network or with your game, and engine will just be able to use this data. But editor will work with some simple standardized data.
Yeah, so I guess that really adds a lot of ability for people to modify the game. So like if you're going to go join a specific server, it's able to download the maps dynamically instead of having to like reload them as game files or something like that.
Mm-hmm.
Yeah, I think that's a really cool way to practice a lot of that stuff. And so when you have configuration files that allow you to design what is sort of where and stuff like that. But then if you want to add more functionality, so you want some type of scripting language inside of Dotrix that you can ship and have run dynamically as well, be interpreted or whatever. Have you thought much about that yet?
No, actually, I didn't. There are many things to do now. There are a lot of open questions in Dotrix in game, and people sometimes ask in chat if we plan these. Yes, many things are planned, but the time. The main question
Yes,
is time.
of
We
course.
are. This is a side project, and we do our best to make a tool that works for us first of all, and we share it. So if
Yeah,
it will work for someone else, it's just perfect.
awesome. Well, good stuff. I think that's all the questions we have for Dotrix for now, but it's always great seeing the progress on how it's going.
Thank you, Farth.
All right, I'll see you next time.
See you next time.
Okay, so we are back with Connor, CW Fitzgerald, who's going to talk to us about Run 3.
All right. Well, hello everyone. Good morning, afternoon, and evening. This is talking about the next version of Ren 3, which is 0.3. As a reminder, Ren 3 is a 3D rendering library built upon WGPU. It's designed to be easy to use, customizable, and very efficient and fast. It has a very simple API, and uh, yeah, is should be simple to use. So, we're here to celebrate the 0.3 release. Many new features. One is that we now have a proper render graph so that we can now compose different rendering routines in a way that is a lot cleaner than it was before. We have WASM and WebGPU support. We have a framework which deals with a bunch of the platform differences between like Android, the web, native. There's quite a few things that are very finicky and that I don't want all of my users to have to all independently discover and write. So this framework provides that set of base utilities. We now use Wixel for all our shaders that can be parsed by Naga. We still write in GLSL, but we now convert from GLSL to SPIR-V using GLSLC, and then we use Naga to convert that from SpearV to WGSL. We have built-in eGUI and InGUI support, and tons of bug fixes, as always. The caveat is, I haven't actually released this yet. Last week was a really tough week at work, so I did not have much time to like work on Ren 3, so I'm a little behind. But I wanted to talk about all the features that are coming up. Hopefully the release will be coming up within the next week. Maybe sooner than that, but not quite there yet. So the big elephant in the room is WebGPU. And this I actually have a live demo for. Part of the reason I've been writing this framework is so that I can have web GPU support. And if I do, let me see here. So if I build a scene viewer, which is our normal build, I've already built it, blah blah blah. I go and serve that. I can go on regular Chrome, not even Canary. Log into not that one. 800. It loads, and there we go. We have a working Ren 3 in the browser running on top of WebGPU. This is using the currently active WebGPU Origin trial. You can actually register localhost as the origin you want to use. They aren't more than one person can register localhost. So yeah, this is running at what appears to me to be words 144 frames per second because I have a 144p monitor, 144p, 144 hertz monitor. One thing I want to note, and one reason why this framework is so important, getting input and other things like resizing working on the web is actually a real pain in the ass. The web in general creates a lot of work for your event loop. And hi Jesse. And so because of that, there's a lot of WASM specific code that there's a lot of WASM specific code that you need to make resizing work, and that's why this isn't full screen yet. Is because I haven't done that yet. It's a lot of work. Input management is different. The fact that everything on WASM needs to be async, so if you have any locks at all, those need to be async locks, which means now your event loop needs to be async, which means you need to be using message passing. And like it gets complicated very, very quickly, and I don't want all of my users to have to deal with that. So anyway, so that's the big thing. This is a functional in the browser. I will have this on the web at ren3.rs, which I won't link because it's just currently a Jekyll default site. But once I have that up there, you'll be able to go on and like play with all the examples and see this work in real time. All right, so back into here. All right, so just brief talking about the render graph. I'm not going to go into. Oh man, sorry, my allergies are killing me. So I'm not going to go too deep into the render graph. It's like we can talk about how to do render graphs and all the like what you put where, how to structure them like all day. So I'm just going to talk about the very surface level stuff. If you're interested, come see me after. So the main thing is it allows for composability of render routines. I can modify any step in the graph without interfering with all the rest. If I want to say use a different skybox, I can run a new skybox routine, plop that in the graph. The rest of the code does not have to care. You can do that. You want to add your own passes. You want to add some pre-processing. You want to add post-processing. Whatever you want. You can just add that, and the rest of the code does not need to care, as long as it can match up the inputs and outputs. And as you can see here, you declare all of your outputs and your inputs. currently they're matched based on strings. I may change that up in a future release. But for example, you grab the HDR depth as an input. This is for the skybox. So the skybox doesn't actually write to depth; it only reads from it. So it just registers it as an input. It registers the color texture as an output. It builds a render pass. It declares a render pass, and then it grabs some arbitrary data from the graph that says, "Oh, this is the uniform data for the forward pass." And then inside, this is all one function, just split in two. So inside the actual execution of the graph, of the node, sorry, you just get the render pass and get the data that you requested, and you just use that render pass to draw whatever you need to draw. The render graph automatically merges render passes so that if you have the same input and output, it just reuses the previous render pass. And it also has support for if you have it. You know how in WGPU, if you make it temporary within a render pass, it's going to complain to you because it doesn't live long enough. This is obviously a big problem if we're sharing render passes. So we have a system built in that is basically an arena that you can say, here, I have some temporary data, allocate it long enough for this render pass, please. And it will return to you a mutable reference that you can use, that you can then pass into WGPU functions. This is all handled internally with a very carefully written set of 4 unsafe cells. I believe that all of my code is sound, crossing my fingers. But that is the big thing, is that you get to have all of this. The code works in sort of nice segmented bundles. Like you have this part that just does the skybox, and that part which just does like the forward opaque pass. But the GPU needs these things merged because that's how it runs efficiently. That's how mobile GPUs do things quickly. And we don't want to sacrifice code quality and mean that all the code has to know about everything. So we have this system built in to implicitly connect those pieces for us. And this not only means that all of our render routines are actually significantly less code, it is much more extensible and much easier to use. I'm sure there will be hiccups as people outside of the outside of Ren 3 itself start using it, but we'll cross those as we come to it, and it's a very promising start. So the other big thing is the framework, and this is not a. I'm not trying to be like something like GG Easy or one of those big frameworks that does a lot of things for you. I want to deal with the rendering related stuff that no one really wants to deal with because it's annoying and it's very finicky. So making sure logging is set up, making sure that how you spawn tasks is different on native. On native you use Tokyo or Async Standard or whatever. Whereas on WASM you have to use the WASM bindgen like built-in executor. Asset loading, because on the web there's no file system, so you have to load over the network. These are the asset loading in particular is a simple solution. It will not work for everyone, but for most people who are just like, hey, I want to port my thing to the web, it will make it very easy to just like follow the one rule of where you drag your resource folder, and it will just figure out the rest. So, then there's input, resizing, cursor grabbing. They're all very platform specific, and often Winit can't deal with it for one reason or another on the web, because the web's different because you're a canvas inside a document as opposed to like a window on your own, so you sort of don't own yourself. Surface reconfiguration, there's a bunch of gotchas there, especially on Android. I don't want people to have to deal with that. It's just messy and annoying. So it won't handle all cases, but it will handle the majority of people's cases when they're not doing anything terribly complicated with their event loop. and of course, you'll still have access to all the events, even so you can implement custom behavior on top of that. So WASM, Android are two notable things that it's just tricky. So we use a trait so that we have default implementations. So for example, if you don't care how we make a window, like if you don't have any custom functionality, you just like use the existing function. You don't implement it. All of these functions have default impls that either do the default thing or does nothing. Um, so putting this all together, you can have most of your event loop. Most applications will be able to use this framework to make their event loop and to make their Ren 3 devices and such like that. So framework isn't mandatory, of course. This is an add-on top of Ren 3. Most examples will use the framework because that's part of the reason why I'm writing this. But there will always be an example without it, though likely the simplest example, so you can see how all the pieces come together if you aren't using the framework. That being said, it likely will only support native. So that, because I don't want all of the complexity that we run into the framework also on that example. So yeah, that's about that for Written 3. Here are links as always. We have a Matrix chat room. I also have a Discord for the project that this is allegedly part of. If you join there, we have a Ren 3 channel, which is a mirror of the Matrix. So you'll never miss conversations by being in one or the other. So just choose your preferred platform. There are people on there who talk from both. Acknowledgements. Thank you everyone who has helped out, given feedback. It means a lot. If you want to help out, we have tons of stuff to do. Always come to the Matrix or Discord. Finally, that's it.
All right, cool. So I think we have a few questions in chat. One thing that someone's wondering about, how do you register localhost as an origin trial? Did one person register it and now it works for everyone?
No, you just register it. Origin trials aren't global. They actually aren't like. It's not like registering a domain or something. So you don't have to prove you own it. So you literally go in, you type in the origin you want, you hit enter, they give you a token,
Ah,
and you
okay.
put your token in that. You put the token in the HTML or the response headers, one or the other, and that's it. So you can use localhost because it's just another origin. Um, yeah, that's how that works. And you need to give feedback once a month to renew the origin trial. Um, which will be interesting because I have to give feedback twice now because I have two domains registered.
Copy paste. All right. So another
Uh,
thing that I'm sort of wondering about, in like the last few months, how has the community been going for Ren 3? Because I know there's a lot of different projects that are starting to like use it as their rendering backend. And so what have you sort of seen on that front?
it's glowing. It's growing, slowly but surely. Uh, every I don't know, every couple days we get someone new who's either coming in who wants to help or wants to use it or just has some questions about it. I'm always surprised because they always seem to come out of nowhere. They
Yeah.
just show up. But yes, we're slowly growing. It's not large by any reason, but we got 2,200 stars on GitHub. We're slowly, uh, we're slowly building up. Uh, that would definitely is not the link.
That is not the right one. Okay. I forget. I pulled it. I thought I pulled it from the like there's like one channel in Discord where it's like a lot of stuff.
It's RxJ.
Oh yeah, that's. Oh yeah, that's my bad. I copied it right from the direct messages because I was trying. Okay, that was my bad. That's my bad.
Okay.
Um.
Uh,
So yeah, so like I guess like seeing more people using it here and there, and then I guess engines might start using it as their backends as well. So have you seen much of that other than I guess like are you building your own like sort of front end for it or?
I will eventually use this in a game. It requires me to have time, so
Yes.
that probably won't happen for the next year. Um, because I'm working on this thing most of the time. Um, so I am not personally using it um, right this second, but I don't I don't know if I have how many active engine projects we have. We don't have like a formal list anywhere, so it's not like I can go and quick look. Probably should start making one. I know WGPU has one.
Yeah, that'd be kind of cool to
Um,
see just like where it's being used and stuff like that. I think a lot of people like if you kind of come in with a little bit of understanding of graphics, it's very difficult to place like where Ren 3 fits in like a pipeline that you might want to use. And so kind of just seeing
yeah,
where other people are using it would be pretty nice, I think.
yeah, totally. Yeah, I also should improve the. I mean, this is of course a continuous struggle, documentation and like when you go on the README, can you really figure out what I am?
Mhm. Mhm.
So
And I mean, like you have pictures and stuff, and I think pictures are worth 1,000 words in this type of context where you can kind of see, like, okay, like this is what it's like trying to accomplish, and like this is what it's where it's at right now and stuff like that. But then, sort of
mhm.
like on that topic, when you're doing like when you're shipping for the browser, I know that there's often a lot that like you might be able to give to like a native game that you can't necessarily do in the browser. So what kind? I mean, you talked about like a few hurdles, but what are some of like the biggest things that you'd really like to see be able like that you could do in the browser that you're not able to right now?
um, so the big thing is I have Ren 3 basically has two different rendering modes. It has a GPU powered rendering mode and a CPU powered rendering mode. The GPU powered rendering mode is super fancy. It does a bunch of culling on the GPU and then just like renders the whole scene in three draw calls. Um, whereas the CPU mode is a lot more standard rendering where the CPU does everything. Uh, it changes a texture, it calls a renderer. It changes a texture, it calls a renderer. That kind of thing. So I would love to be able to have the features that I need to do GPU based rendering on
Hmm.
web, but
Yeah,
that is unfortunately probably going to be a long way away, considering that the web GPU origin trial just got pushed back even further. Um,
I
so we're
see.
not even looking at V1 until possibly mid end of next year.
Yeah, okay.
So on top of that, asking for descriptor indexing or binding indexing, whatever we call it, is a lot. I'm hoping to get native support into WGPU soon without because currently to use descriptor indexing you have to use SpearV pass through. So
Hmm.
hopefully we can get that natively supported in Naga and WGPU.
I
Um,
see. Yeah, so a bit of a long path on some of the blockers there, I guess.
yeah, it's one of those things that I'm very happy that I can support web
Hmm.
and that the CPU mode could be easily adapted to support web. Um, but I I'm not going to be too fussed if it's not the fastest thing in the world because I will almost guarantee you it will be faster than WebGL. So,
That is good.
and of course, any optimization I do on the CPU path
Hmm.
for native will also improve for web because the CPU path is that lowest common denominator base web GPU
Hmm. Hmm.
um, versus the sort of advanced more uh, and do more things, which is basically targeting desktop.
Yeah, yeah. All right. Well, I think that's it for questions for this month. So it's great to see the progress on Run 3. I hope to see you next time.
Yeah, thank you.
Okay, and finally for today, we have Kevin here to tell us about what's been going on with the graphite world.
All right. Yeah. So this is a presentation for the past 2 months of work because both myself and my co-collaborator, True Doctor, have been busy with mostly school things, as well as a bit of background research going into a bit of future work for Graphite relating to the render engine. A real quick overview. If you're not familiar, Graphite is an in-development graphics editor for creating 2D and 2D vector and raster-based graphics. You can kind of think of it like a open source replacement for Photoshop or GIMP, as well as for Illustrator or Inkscape. And additionally, it combines a node-based workflow with a more traditional workflow, giving you really powerful node-based editing capabilities for creating procedural content that mixes nicely with your more traditional WYSIWYG, what you see is what you get, interactive kind of tool-based workflow. So combining those together, we're basically creating what ultimately would be kind of a visual scripting language for chaining together different Rust functions that are domain specific to graphic stuff. For example, creating various Bezier curve shapes and turning them into artwork and graphic design and illustrations, as well as digital painting, where you can draw things with a mouse or with a pen tablet and create actual artwork. Additionally, all of this is resolution agnostic, meaning that after you draw things, you can zoom in forever, just like how you can do that with vector art. You can also do that with your paintings. So on that note, before I get into the updates, I've been working a bit on learning how WGPU works because that will be the next phase for our actual render engine. At the moment, our prototype is just using SVG rendering that is provided by the browser. And at the moment, the way that works is we are basically creating an SVG code that gets sent to the browser, and then the browser updates it. However, all of the code is written in Rust, and it's compiled to a WebAssembly, and then basically the entire application code runs in that WebAssembly module, while the browser is basically just a thin UI layer that has a little bit of glue and a little bit of HTML and CSS and Vue.js that's used for rendering. But then the main actual business logic occurs in our Rust module that's running in WASM. In the future, we will have a native client as well. So I've been learning some of the WGPU stuff. I've been kind of building a small game engine that is used for doing post-processing effects and rendering the Sponza scene and a little bit of things like that. So thank you to ZW Fitzgerald also for answering my many questions. And then also True Doctor, who's the co-collaborator on this, has been learning some compute shader things as well. That'll come in very handy in the upcoming year as we continue to implement the render system. So for updates this month, actually that should be this past 2 months because this would be through September, because we had a little bit of a slower progress this past 2 months as we did that research and both of us returned to school. But basically, we did some improvements to TypeScript type checking. That just improves the type checking quality. We also have now changed the way that it's set up so that our automated license inclusion does not get included in dev builds. This speeds it up and also makes it so developers, if they're not creating a release build, don't actually have to install the cargo about package on their developer machines. And then, let's see. Document tabs are now also tracked by their ID, not their index, which is just a small thing that's going to allow us to make it more easy to rearrange tabs in the future. Ruler dimensions now are fully interactive, which is actually pretty fun to play around with. I'll show you that in the demo. We have upgraded to the Rust 2021 edition, which is exciting. And we also removed an 82 megabyte Node.js package that really didn't actually do much. It was supposed to be used for importing SVG code, but we managed to replace 82 megabytes of code with a 4-line JavaScript file. That's part of our build system. Yeah, that reduced the entire the entire node modules folder from about 300 megabytes to about 200 megabytes, which is still a lot, but it's a huge improvement for removing one unnecessary package just for including SVGs. And also, we have made it so now users are notified if they're using an old version of Safari, which was not supported by Graphite because it did not support a certain JavaScript API that was required. But now that Safari 15 has come out, that is included, and now it tells people to upgrade. And finally, I've been working on designing the website further. This will probably launch at the end of the year, and I'm pretty excited to launch this because the design is looking very nice. So here is a live demo. Okay, so let's see, of the things I can show. The document IDs, basically that is these different tabs here. Internally in the backend now, these are tracked by an ID that is assigned as they are created. Every time you create a new tab, it assigns a new ID that increments. And that way it's not using the index, which will make it possible in the future to drag these around left and right, and also drag them around to different panels around the UI. Also now we have the rulers. It might be a little bit difficult to see on the stream, but these all say like 0 and 100 and 200, 300, 400, based upon the number of pixels. So if we draw some shapes and things now, and then we pan around the document, we can actually see that the ruler labels follow us around. And this is accurate to the number of pixels that are being drawn. If we go from 100% to 200% scale, for example, now instead of showing from 0 to 100 to 200, it's actually saying 0, 50, 100, 150, 200, 250, and so on. And we can continue to zoom, and it will continue to add more increments as we go, getting to some very small numbers as we continue to zoom in a whole bunch. Or we can zoom out a bunch, and we get much smaller numbers. Now it's every 200. Now it's every 400. Now it's every 1600. And if we go back to this, then it basically it moves around on the left and right axis and the top and the horizontal and vertical axis. And I think that is all that I can actually show you because the other things are not something I can trigger at this moment. And they're more back-end code related stuff. But that is the demo for this month. So back to the presentation real quick. Yeah, so we have plans now, updated plans for the release. It's been something that we kept expecting to release the Graphite Alpha or 0.1 version for the past several months, but it has been continued to push back as the number of tasks has been realized as larger than it seemed, and also school has gotten in the way more than expected. But with that said, we're relatively confident that we'll be releasing at the end of the year or in early January. That will include the website release at graphite.design. Currently, if you visit that, it redirects to GitHub, but that will be launching as a proper website. And additionally, the alpha version, basically the major things we have to complete now is the pen tool and Bezier curve editing, as well as the property panel where you can edit the properties of each layer, and then also snapping between layers, which has been in progress, but will need a little bit more polishing before it's merged. So we have 2 sprints left. That's the upcoming sprint for the month of November, and then also the sprint for December, and then that should culminate hopefully in the release of the alpha version and the website. Just like to thank our 2 new members who have contributed code that got merged this month. That would be C. Othman and P. Swan on GitHub. And hopefully, if you're interested in joining us, please take a look at the project on GitHub and join our Discord server. You can visit discord.graphite.design, and that'll redirect you to our GitHub link, to our Discord link. And with that said, are there any questions?
All right. It's always cool seeing the new progress, and I think especially with like the alpha. So I love that you have like a deadline of 2 months, or like where when you sort of want to be to that, because like having worked on Valorant for such a long time, we're always just like, well, we could really never put it into like calling it a beta or something. We kind of keep pushing off version to version. But I think that's super awesome, and super excited to hear that there's a date for that. Um, and so one question I was sort of wondering about is I know that the system that you've been working on to essentially be able to get a lot of UI into the browser. Like you put a lot of work into getting like a front end framework set up for that, and get like the Rust pipeline ready for that. And so what I was sort of wondering is like, is it almost at a point where you can take all of what you've learned and either distribute it as its own crate for other people who want to make these types of UIs in Rust, or maybe like package it up in like some type of blog post, or kind of like see what you can do to help other people get UIs like this in the browser.
Yeah, I think sort of the browser has actually sort of been a means to an end for us. We wanted to have some sort of UI that is very robust and something that I've been personally familiar with as someone with many years of web development experience. But the goal has actually always been to replace the web-based UI eventually. So that's why we architected it in a way where the front end is very decoupled from the back end of the editor. And then also further down in the architecture, there's also the document system, the document graph engine, and then even below that is the render engine. That's kind of the major pillars of our architecture. Um, but so that said, we're not really putting too much work into the web aspect of things because the goal into like the architecture and sort of possible spin-off dependencies that could be used by other projects. The goal has always been kind of to replace it, and it's to use it for hopefully no more than a year or two.
Hmm.
So unfortunately, we're not really planning on doing that. And also, I think the way that we're architected, it's basically just one JavaScript file that is in charge of receiving all the messages sent by the backend, and then one Rust file that is in charge of sort of being the federator of all messages within the internal system as they get sent to the front end. So it's just sort of a relatively simple architecture where there's sort of a central point on the front end and a central point at the back end where they communicate with each other. And then from there, they all just get spun off into their specific parts of the UI on the front end in the JavaScript world, and then the very specific parts of the Rust architecture, which are very specific to the Graphite application.
Okay, yeah, that's I suppose like yeah, once you kind of have some experience on what the architecture should look like, then you learn a little bit about like what types of things like need to be decoupled or separated or anything. But then also, I mean, like you have very large aspirations for a lot of the different parts of Graphite, in that like you have this like notion of a backend, and so you have to really think in primitives of if multiple people are working together, what does this look like from the backend perspective, and how does this translate to what you're showing on the front end. So there's definitely yeah a lot of large problems that you're working on solving.
Yeah, that's definitely true. And we actually kind of have two backends or two things that qualify for that word backend. We have the WASM module that is essentially running all of the code, all of the business logic of the application in that WASM module. You can kind of call that the backend. It's not running on a server though; it's running locally in your browser. And then in the future, and we've actually been prototyping this a little bit in a few past months. We've shown off a demo of it, uh, and that is the collaborative editing part, where we actually want to architect it in a way that allows us to make it so kind of all the messages and all of the operations that users are doing can be streamed over to a server. And as a result, multiple people can edit the same document at the same time and have a live, kind of like a Google Docs like experience as they edit together. And that requires additional architectural considerations where essentially we can't assume that you are the only user and certain actions that are being done can't be assumed as happening by a global system. They have to be acted upon by a single user out of
Yeah,
potentially many.
yeah, and I think like this sort of comparison with Google Docs is interesting, because when you think of Google Docs, like if two people are typing on the same sentence, then it has to do a little bit of resolution where sort of like the characters have to line up, or like what's happening. But then on the other hand, if we think of something like Figma, Figma is a lot more discrete in what you're doing, where when you like click and drag to add like a square or something like that, then it's more difficult to really overlap at the same time. So I think Graphite's sort of in the middle, where you are able to really do a lot of quite large things that could change what other people are doing at the same time, or could have types of conflicts. But then also you do have like everybody can just be dragging circle their own discrete circles onto the screen at one time. So it's yeah, sounds like a really hard problem to sort of have to think through.
Yeah, it definitely is a hard problem. A lot of those are actually going to be essentially everything that you draw, all the circles that you might drag on screen or anything else, or even text that you might edit in the text editor or in like a text element if you
Hmm.
start changing the text. all of those end up basically propagating to the parameters of each individual layer in the node graph.
Okay.
Just a terminology thing. What we're calling, what are normally called nodes, those are actually equivalent to layers. So we're just calling them layers, even though they're in the node graph. But basically, all of that ends up in the graph, which basically is a description of the document. And all of the different deconflicting things that have to happen in any kind of collaborative scenario, those are all part of the graph. So essentially, we have to basically think about things like a graph more than we have to think about them like text,
Yeah.
which Google Docs does, or like, I guess, a set of layers that Figma might use.
And then sort of like leading on from this, one of the questions in the chat is like, if you're going to be doing a lot of this node stuff, then are you going to be like embedding a like compiler into, well, I suppose it could be embedded into the back end, but there would have to be like a compiler that could be able to reason about, or interpreter to reason about these nodes working together.
Yeah, that's right. So the way that that's going to happen is that the native installation, once we have a native executable that is not running in the web, but it's actually running as a direct desktop app, that will either include or reference your Rust installation. And basically all of our nodes that you create will be small functions, or not necessarily small, but they are essentially a text file, and you can write Rust code in them. So you might have, for example, a node that is used for the purpose of, um, let's say you're given, an image as input, and you want to find all the red pixels and remove them and turn them into to black pixels. Then, if you wanted to do that, you can write a Rust function, or you could probably do it by just chaining together built-in nodes. But just for the sake of this example, you can essentially write a Rust function that reads through all the input data, and for each pixel that is red, it would turn it into a black pixel. Your Rust function essentially is going to be using a little bit of a standard library that we write that basically provides all the data types. And then once that gets compiled, it'll be turned into a WASM module that actually runs in a WASM sandbox. And that way, we don't have to worry too much about security concerns with arbitrary code execution, because it's all running inside of a sandbox. And essentially, yes, all of those, the code that you write will actually be written inside of a text editor within Graphite, in the actual GUI application. But then we compile it on the fly. Basically, just your module is just the only little piece of code that runs, and it gets turned into a WASM module. And then the compiler is going to be either referenced on your system if you already have Rust installed, the Rust toolchain, or it will be embedded in the actual application when you download it, if you choose to download the larger version, which includes all that. Or in the web context, it'll actually run on a server, and basically it sends your JavaScript. It'll send your Rust code off to a server. The server will do the application, do the compilation, and it will momentarily send back a WASM module that is then run in your browser.
Okay. And so I think, yeah, definitely this idea of being able to ship something that allows you to compile Rust code is really interesting, in the sense that when you're on the front end, if you want to do some like very mathematical type of art or something like that, it would almost allow you to like maybe embed different types of creative coding crates like Nanu or something like that, where you can have Nanu be used to draw a really like interesting pattern as part of the background or something like that, and then you would be adding more stuff on top of it in the front. And so I think that opens the door to like some types of like almost like real time art that you would not necessarily have been able to do with like Nanu in like a creative context. So yeah, that's quite interesting.
Yeah, absolutely. It's kind of, you can think of it like Graphite is a node-based editor that would allow you to include crates such as that, and then combine that together with what I'm sort of calling the standard library for Graphite. It's sort of all of the data types that are used, such as vector graphics, raster-based graphics, different sorts of data like that that are used in the render pipeline provided by Graphite. So we provide essentially the rendering, we provide the node-based environment for creating and editing, and also sort of the runtime, I guess you could call it as well, which is basically all the code that's used to take in data. And for example, if you're, I don't know, you might grab data from a weather API, and you could turn whatever
Oh
the current
wow.
weather is for your location on that day into a graph or into some sort of graphs or graphical images that might get run, I don't know, once a minute in a cron job, and then it'll display on a screen that your Raspberry Pi on a wall of your house or something can have. So that's just an example where you can use all those creative coding applications and crates and then write your own code for specific nodes and then combine it together with the entire pipeline of the Graphite ecosystem.
Yeah, and so I'm kind of getting this idea that when you're talking about nodes or like layers in this type of graph, layers can be a lot more abstract in the sense that like maybe a layer contains information about like how often this job needs to run, or this layer contains something about code, or something that's not directly like something that you see on the screen, but can be like a lot more dynamic.
Yeah, so some nodes might take in and just process standard vector data, some might process standard raster data, but others will include things like string manipulation. There might be a regex processing node, and it takes in inputs of strings and gives outputs of an array of strings, where you can have like entire spreadsheet data. You can read a database or you can read an Excel spreadsheet or a CSV file, and that entire block of data can be processed and run through different nodes. Some of them you'll actually write yourself in Rust. Others you can use standard things like the regex processor or other nodes that are kind of built in for useful data processing, and you could almost say like data science applications like that.
Yeah, I think definitely like that's sort of what I'm thinking, is that this could give you a different way of visualizing stuff that you might have done with like Jupyter notebooks or like other Python libraries or something, like just like exploring it differently. And I think the one place that I really love seeing this type of thing is Advent of Code every year. A lot of people will be like answering the questions, and then someone will be like, "Oh, this is like this questions would be really cool to visualize in this way." And so I think Graphite could like really allow people who might be like doing like a lot of Rust code in the first place to visualize a lot of the advent of code questions in cool ways.
Yeah, definitely.
Yeah,
I'm looking forward to when we get to start implementing this. This is the next major pillar of our roadmap.
nice.
Once we have the 0.1 release out, then we'll begin working on the actual node editor. At the moment, we've been working essentially all hands on deck to build some sort of interface, some sort of editor environment. But then the node-based stuff comes next, and that'll be pretty exciting.
Yeah. And then on that topic, another question from chat: will you allow compute shader nodes and or GLSL shaders as nodes?
Yes, definitely. So we will be specifically supporting Rust GPU, which is the project from Embark Studios that allows you to compile Rust code directly to the GPU. So that will be essentially the way that you can write a lot of things for high performance GPU based stuff, both compute shaders as well as fragment shaders or pixel based shaders. So essentially, my example of replacing red pixels with black pixels would probably be run actually as a pixel shader, and you would write it in Rust still, but it would have some decorators, or sorry, what are they called? They're called attributes in Rust, on top that allow you to basically tell it that it's going to be compiling to the GPU using Rust GPU, that project. So as a result, you can either write CPU-based code or GPU compute code or GPU pixel code, and all of those run in their respective pipelines based upon the type of node that you're using and how it's set up to process data.
All right. Yeah, so it sounds like there's a lot of super exciting stuff. So I guess we'll be interested to hear next month how you're progressing towards the alpha.
Yes, definitely. If anyone is interested in the project, please join. The link to the Discord would be just in your browser, discord.graphite.design. So please join us.
All right. Thank you so much, Kevin. I'll see you next month. source, back to Chrome. Okay. Oh, that worked right away. Nice. So, we are at the end of the show for today, so I got a few announcements to go through. First of all, this was pointed out to me, I think yesterday. There is an event that's going on November 20th at 3 p.m. CET. It's called Rust and Arts, and they don't have too much information about the schedule just yet. But I do have the links here, so you can go check out a little bit of stuff about it. From what I understand, it seems like artists will be coming in and talking about what types of stuff that they're doing in Rust. So I'm assuming there might be some stuff with like Nanu. There might be some stuff with either creating creative coding libraries, or other video games or graphics in general. Now, the interesting thing though is that they put in a little thing here, and it reads, at the Rust and Arts Edition event, we will be showcasing unique Rusty games and art projects during the breaks. And it's still not too late to apply if you want to get your game or project an extra couple of eyeballs for free. So if you go to the website, you go to the more info link that I have on here, you can send them an email and see if they might want to check out, or like allow you to just show off the game that you're working on. Also, all of the slides that I have will be available on the Rust Gamedev YouTube channel when I post this video. And then because of that, I'll also have all of the links from the previous projects that were discussed today, so you can go check those out. So Rust and Arts looks very cool. The newsletter is out, the Rust Game Devs newsletter. I should I'll put a link in there so people can access it from the YouTube video. But this is just a newsletter of all of the stuff that has been happening in the Rust Game Dev world over October. And so lots of people talking about the games that they're working on, different libraries, different crates, and stuff like that. Also, the Rusty Jam is working on getting a second iteration set up. So currently it's planned for around the end of November, but we might be pushing it back a little bit into December. But if you missed out on the first one, the Rusty Jam is a game jam where people will be working on games in Rust, and so you'll have about a week to work on a game, and you can use any Rust game engine. You can use Rust and Godot. You can use no game engine and play hard mode. But I mean, if you're going to make a terminal editor kind of, or a terminal type of game, that could be a good way to go. So keep an eye out for this. If it's running in December, then hopefully the meetup will come before it, and I can announce more about the details of it. Also, the Rust Game Dev working group meeting is back. So I've hosted 2 of them so far. In the first one I hosted, I was the only person who attended because I didn't advertise it at all, and so I mostly just kind of wrote down some ideas on what I want to do to advertise it better and what I want the meeting to try and accomplish. But then the second meeting, I sat down with Oscrip and we talked a little bit about how we can get more people from the working group itself, so like the team members coming out to the meetings, how we can schedule it at better times. Um, but I'm going to try and find times that work for the most people possible. So essentially, it will be the one in the first week of a month and one in the third week of a month. So 2 weeks apart normally. And each like the first week and the third week will have probably meetings on different days and at different times to try and accommodate as many people as possible so that you can hopefully make it to at least one of the meetings. But again, we're still figuring out how a lot of the stuff is going to work. Now, I haven't updated the specific discussions that are here, but on the Rust Game Dev working group, you can actually go to the discussions tab, and I have created a discussion for the third meeting, and so people can maybe talk about what types of things they want to see in the agenda. And then going forward, I really want to promote this. So like if people are like, maybe this part of RB Game Yet could be improved, or we'd like to see this initiative moving forward, then we can start discussing these things during the agendas. Um, yeah, so that's it for today's meeting. There's not actually anything extra this time around. And so hopefully we'll see you all next month with some cool projects. See you next time.